Electron emission. All the metals have free electrons. These free electrons are held inside the metal surface by the attractive forces of the ions. If sufficient energy is given to the free electrons, their kinetic energy increases, and thus the electrons will cross over the surface barrier to leave the metal. This minimum energy required by an electron to escape from the metal surface is called the work function of the metal. The liberation of electrons from the surface of a metal is known as electron emission. The work function of the metal, denoted by phi naught, is measured in eV, electron volt. 1 electron volt is the energy gained by an electron when it has been accelerated by a potential difference of 1 volt, so that 1 eV is equal to 1.602 into 10 raised to power minus 19 joule. The values of work function of some metals are given in table. The work function of platinum is the highest. Phi naught is equal to 5.65 eV, while for cesium it is the lowest. Phi naught is equal to 2.14 eV. Electron emission can be achieved by any one of the following physical processes. Thermoionic emission. In this method, the metal is heated to sufficient temperature to enable the free electrons to leave the metal surface. The higher the temperature, the greater is the emission of electrons. This type of emission is employed in vacuum tubes. Photoelectric emission. When light of suitable frequency illuminates a metal surface, electrons are emitted from the metal surface. The greater the intensity of light beam falling on the metal surface, the greater is the photoelectric emission. Field emission. In this method, a strong electric field, high positive voltage, is applied at the metal surface, which pulls the free electrons out of metal because of the attraction of positive field. The stronger the electric field, the greater is the electron emission. Secondary emission. In this method, a high velocity beam of electrons strikes the metal surface and causes the free electrons of the metal to be knocked out from the surface.